Hello. In this question, excitation energy in Lyman last line. It means here N1 1 and initial is 1 and final infinity is ionization. Or in reverse case, this is the emission spectrum. So whatever energy here, that is minus 13.6 electron volt, here 0. So the difference here is 13.6. This is called positive energy. This is called ionization energy because the electron is removed to say infinity. So this is called ionization energy. Means option 1 is correct, and it is called say absorption last line also. So option 2 is correct. Last absorption line of Lyman series. So both the options are correct. Means option correct option here is 3. 1, 2 both are both correct. In this question, according to Bohr theory, energy radiated here in the transition from third excited state means n is equal to 4 to n is equal to first excited means 2. So energy given as minus 13.6 upon n square here in electron volts. So energy can be found here, energy difference minus 13.6, that's common here, 1 by 4 square minus 1 by 2 square. If we solve it here, it will become 1 by 16 minus 1 by 4. That comes here 2.55 electron volts. So option 3 is correct. This much energy did. In this question, energy is absorbed. It means we are moving from lower orbit to higher orbit. Then it is the absorption spectrum. So here it is only possible in lower to higher, 1 to 1, second is not possible, higher to lower third and higher to lower not possible. The absorption is n equal to 1, 2 and dash which is higher than 1 means this is the case of absorption. Only option 1 is correct. Hello. In this question, electrical current I created by the electron in the ground state using the Bohr's model. So we know the formula of current is equal to charge of electron divided by the time period. Time period means distance means perimeter of the ground state upon speed. So current can be taken as EV naught divided by 2 pi of A naught, so equal to EV naught upon 2 pi A naught. A naught is the radius, V naught is the speed. So option 1 is correct. Hello, in this question, Rydberg constant and for 7 per meter is given and wave number, the last line of Balmer series means here the wave number 1 upon lambda equal to r. If it is a Balmer series, so here 2 square to last line means infinite, means it is r by 4. If we put the value of r per constant and for 7 upon 4, so after solving we are getting here this much wave number. So option 1 correct. And this question you have to find out the ionization energy means here the energy is minus 13.6 electron volt. The same energy we have to provide. So required energy here is positive 13.6 electron volt. It is called ionization energy because we have removed the electron from first orbit to finite. So option 4 is correct. Hello, in this question, radius of the innermost orbit means n is equal to 1 is 5.3 into 10 to the power minus 11. We have to find out the radius of n is equal to 2. So we know radius Rn is equal to say n squared radius of first orbit is given in the question, say 5.3 into 10 to the power minus 11 meter R1. So Rn means 2 square into 5.3 into 10 to the power minus 11 meter comes here 2.12 angstrom in angstrom, that is 10 to the power minus 10 meter. We have converted here to angstrom. So option here is 2. So in this question, if electron in hydrogen atom jumps from third orbit to the second orbit, it emits wavelength lambda. When it jumps from fourth to third, we have to find out the wavelength emitting light. It is lambda dash. So we have to find out lambda dash in second case. Here, say as per the question, 1 by lambda equal to r Rydberg constant 1 upon say second orbit 2 square minus 1 by say 3 square. We solve it. 1 by 4 minus 1 by 9 is here. Calcium 9 minus 4, that is 5. So here 1 by lambda is given by equation 1. The second case 1 by lambda dash, that is r, here 3 square minus 4 square, r 1 upon 9 minus 1 upon say 16, taking LCM 9 into 16, here 16 minus 9, that is a 7, equation 2. If we divide equation 1 by 2, we get here lambda dash upon lambda and r 5 by 36, r 7 by 9 into 10, the 4, so it is say r also cancel out, 5 4 just say 20 divided by 7, so lambda dash will be 20 divided by 7, lambda, option 3 is correct. So, in question 49, moment of the momentum means angular momentum. Moment of the momentum means angular momentum in second orbit of hydrogen atom. So here the formula of angular momentum is mvr equal to n h upon 2 pi. For the second orbit, it means n is equal to 2. So 2h upon 2 pi to cancel out. So this L dash or for n is equal to 2, it is given as h upon pi, the angular momentum. So option here is 1. In this question, electron is revolving in nth orbit and radius is given 4.2 angstrom, and R1 ground state radius is 0.529 angstrom. We have to find out the value of n here. So the radius का formula होगा n square R1 and it is given in the question 4.2 angstrom and we do not know R1 is 0.529 angstrom. So n square will be 4.2 divided by 0.529 and n will be root of it. If we solve it here, that comes here 2.817, so n approximately 3. Option 4 is correct. Hello, in this question, we are taking hydrogen, deuterium, singly-ionised helium atom and say doubly-ionised lithium atom. All are moving from second orbit to first orbit transition. So electron is moving from second orbit to first orbit for all. Where we have given say lambda 1, lambda 2, lambda 3, lambda 4 are the wavelength for hydrogen, deuterium, singly-ionised helium atom and doubly-ionised lithium atom. We have to find out the relation between lambda 1, lambda 2, lambda 3 and lambda 4. Now we know 1 by lambda equal to Z square R. Z is the atomic number. Here 1 by 1 square minus 1 by 2 square. So that is Z square R and 1 minus 1 by 4. So 3 by 4. It means here lambda, everything is constant here. So lambda is inversely proportional to Z. Now का Z बड़ा होगा वो lambda कम हो जाएगा. So for lithium is the maximum Z3. For helium is 2. For deuterium and hydrogen here Z equal to 1. And reciprocal of this, so lambda 1, lambda 2, lambda 3 and lambda 4 is given as reciprocal. Lambda 1 ज़्यादा होगा, so it is 1 by 1 square, 1 by 1 square, 1 by 2 square and 1 by 3 square. It say 1 is to 1 is to 1 by 4 and 1 by 9. If we multiply here, so lambda 1, lambda 2 can be written as lambda 1 equal to lambda 2 because both are same here. 4, that is 4 times lambda 3 and it is 9 times lambda 4. In this ratio, so these are the relations here. Option 3 is correct. In Geiger and Marsden experiment, In case of head-on collision, the impact parameter B we have to find. Now, if the size of the particles point size, then impact parameter should be 0 because head-to-head collision just center to center is B impact parameter is 0. But suppose its size is some finite, not point size, means B should be not 0 exactly, but it should be minimum. Then alpha particles are bouncing back to this distance. This is called, say, distance of closest approach. For this head-to-head collision, B should be minimum the size of the particle, alpha particle, and the nucleus of gold. So it is the point size, then it is 0. So correct option is second. Here, hydrogen atom initially in the ground state absorbs photon excited to 4 level. Means here you have to find out the wavelength, say 1 upon lambda is r 1 upon 4 square minus 1 upon 1 square, because it is absorbing the energy. So 1 by lambda equal to r 1 by 16 minus 1, that is minus r 15 by 16, lambda will be 16 by 15 r means here Rydberg constant 0.97 in 10 power 7 negative, we are omitting negative sign because the wavelength absorbed, so that's why minus sign comes. Solve it, comes here 970 angstrom. So option 3 is hello. In this question, Bohr's model of hydrogen atom, this is not applicable if the hydrogen or any gas, this is in molecular form. So Bohr's model is not applicable to molecular form. It is atomic form only, and it is confined correctly up in the hydrogen atom, not for the helium atom. So option 1 and 2 both are correct. Here option 1 and 2 both are correct. In this question, we have to find out the radius of orbit of electron to the radius of nucleus. Means simply the ratio here, radius of atom upon radius of nuclei. This is the ratio. Atom ratio is angstrom level upon nucleus is Fermi level. That comes here roughly 10 to the power 5. So atomic radius is 10 to the power 5 times more, roughly 1 lakh more than the radius of the nucleus. So option 3 is correct. Mass of muon is 207 times mass of electron revolving around the proton. First Bohr radius of this atom muon. So muon is the particle, negatively charged particle, its mass is 207 times larger than the mass of electron. We are finding its radius. So here the formula of radius is n square epsilon naught h square divided by pi m z square. Here for hydrogen atom everything is same here, n also same, 1, z is also 1, h epsilon naught e square pi, everything constant other than mass. So radius is inversely proportional to mass. Now radius of muon upon radius of electron in hydrogen atom for n is equal to 1, z is equal to 1, it is inversely proportional to the mass of electron upon mass of the muon. Given here mass of electron upon mass of muon means 207 times mass of electron, that cancel out, so 1 by 207. So radius of muon is 1 by 207, radius of electron first orbit, it is given 0.53 angstrom, 10 to the power minus 10 meter. Solve it, comes here 2.56 into 10 to the power minus 13. So here option 4 is correct. So in this question, energy of nth electron given by this formula is the formula here, it is given in the question. If all the hydrogen atoms are in the ground state and radiation of the frequency, so we know the energy is equal to h nu. So means energy difference divided by h is what? This is the frequency here. If this is the frequency falling or it is say absorbed, sum of the electrons electrons are definitely moving from 1 to 2. Say n is equal to 1, 2, n is equal to 2. Some of the electrons are jumped from ground state to first excited state. So option 2 is correct. Now n is equal to 3 is not involved, so no atom will be in transition to the n is equal to 3 state because it is not given. Energy is only 1 minus 2 or 2 minus 1. So third orbit is not involved. So option 2 and 4 both are correct here. So option 2 and 4 both are correct. Hello, in this question, if the set of atoms is in excited state and after that it decays, means electron is coming from higher orbit to lower orbit, means here emission spectrum is there. So in general answer here is it is coming from higher to lower state, then and only then it is possible to be already excited to the higher state. It will jump from higher to lower state. So option 1 is correct only. The ground state energy is given for hydrogen atom minus 13.6 electron volt. We have to find out the kinetic energy and the potential energy in the first excited state, means n is equal to 2. So here the total energy equal to minus 13.6 electron volt for first orbit. Now for second orbit, total energy for second orbit is given as 13.6 upon n square means 2 square. So that comes here minus 3.4 electron volt. Say numerical value of total energy, because it's negative, just equal to the kinetic energy. So kinetic energy is required here 3.4 electron volt and potential energy is double of the total energy or kinetic energy. So it will be negative, and this is 6.8 electron volt negative. So here total energy 3.4 electron volt and potential energy negative 6.8 electron volt. So option 3 is correct. In this question we have to find out the potential energy in second excited state. It means n is equal to 3. Now we know total energy given as minus 13.6 upon 3. So this solve it here, comes here minus 1.51 electron volt. Now we know the potential energy is double of the total energy, also negative. So here 2 into 1.51 means 3.02 electron volt. The answer, so option correct, negative 3.02 electron volt. In this question, hydrogen atom initially in the ground state, it is absorbing say some photons or energy. It excites to n is equal to 5 level. What is the wavelength? So here the wavelength formula here is given. R is say 1 upon say 5 square minus 1 upon 1 square, comes here negative R 1 by 25. It will be 24 by 25, and reciprocal to this, say omitting the minus sign, 5 by 24 R is 1.097 instant for 7 के R नीचे जाएगा तो ये हो जाएगा 7. सॉल्व करेंगे लैम्डा, इट विल बी 95 nano, means it is absorbing, so it takes the energy moving from lower to higher. So this is the absorption spectrum, this is the wavelength required. So it is jumping from 1 to 5. Option 4 is correct. Here in this question, nu1 is the frequency of the series limit, means from 1 to infinite for Lyman series, and nu2 is the frequency of the first line, means 1 to 2 is the frequency required here, and nu3 is the frequency of this series limit of Balmer series, means n is equal to 2 to n is equal to what? Infinite, the series limit of Balmer. And we have to find out the relation between nu1, nu2 and nu3. Here we know 1 by lambda equal to R 1 upon Ni square F square. The emission or whatever energy comes negative, the same energy applied will move from lower to higher orbits. So can write an F or minus आएगा उसको y2 ले लेंगे. So this is the wavelength. Now we know C is equal to nu lambda, or 1 by lambda equal to nu by C. And nu will be C upon lambda. If we multiply it with, say here, this is the frequency, the C lambda multiply current C upon R, and it is say for first, so frequency 1 for Lyman series and series limit here. So 1 upon infinite means this is the frequency 1 equal to RC and 1. Similarly for 2, frequency 2 for first line means n is equal to 1, 2, n is equal to final means 2. The initial final in CR 1 upon 1 is square minus 1 upon 2 is square. It comes here CR and 1 minus 1 by 4, that is the 3 by 4. This is the frequency 2. Now frequency 3 for Balmer series and the series limit CR. Balmer series of 2 square minus series limit means infinite, that's the CR by 4. So we know the equation 1, 2 and 3 for frequency 1, frequency 2 and frequency 3. Suppose here let us take the difference between 1 and 2. So it is RC minus RC 3 by 4. RC is common here. 1 minus 3 by 4, that comes here. CR by 4, that is the frequency 3. So here option 1 is correct. Hello, in this question we are looking say Rutherford model. In Rutherford model, most of the space is empty. Electrons revolve under the influence of the Coulombian force between the nucleus, positive charge, and the electron, and most part of the mass of the atom, its positive charge, are concentrated at the center, mass also concentrated in the center, that is called the nucleus. So first three are correct. But regarding the stability of atom, as per the Rutherford, he said electrons are moving around the nucleus, the attraction force here, positive and negative, and they are coming closer and closer continuously, finally fell down in the nucleus and electrons vanished. Actually, it is not so. At the same time, it is coming closer continuously, it is giving the continuous emission spectrum, but here we are getting the practically discrete order, discrete emission spectrum. So here fourth option is wrong, but here option 4 is correct because option 4 is wrong as per the Rutherford. In this question we have to find out the total energy, and this the total energy is given. The formula here is for hydrogen atom minus 13.61 n square electron volt. So this energy is inversely proportional to n square. It means here this option 4 is correct. So in this question, triply ionized beryllium has the same orbital radius as in case of the ground state and hydrogen atom. We know the relation of this radius equal to n square epsilon naught h square divided by pi mz e square. Here we have to find out n. So for radius of beryllium and radius of hydrogen atom in nth orbit, in first orbit ground state, so then putting the value of for beryllium n square, we do not know, we have to find epsilon naught h square divided by pi m, and z for beryllium, that is 4, here n 1 ground state, epsilon naught h square divided by pi m, z for hydrogen it is 1 square. So this cancel out, everything cancel out here. N square is equal to, after cross multiplication, 4, so n is equal to 2. So option 2 is correct.